Okay, seeing people coming in. Can someone please close the door so we can start? Thank you. All right, perfect. So today is our last session. We're going to talk about measurements in technology. For the ones who are checking the agenda currently, I'm not Rebecca. First things first, we just replace Rebecca. And kindly do see this as the warm up for peers and peers that we're going to have after this session. So to start with, I would like to thank our sponsors again. And I would like for everybody in this room, until we still have some time before the first talk, to give a round of applause to all the program committee members, which have done a very awesome job to get this done. And by now, I would like to call LINX, the road of 400G. Halil will guide us through, right?
We're using these mics, so. It's fine. I think we're okay. We're okay with these, no problem. Right, I've only got 20 minutes and I'm not allowed to make any jokes, according to Fergus, so I'll try and keep it as concise as possible. We're going to talk about 400 gig and our road to 400 gig, should I say, the challenges that we faced and how we managed to get there in the end with the development challenges during a pandemic, which was obviously quite an interesting period to deploy new hardware onto a network. Just a side note, these aren't my slides. I've had the short straw amongst all of us, so apologies if there is any holdups there or repeated words. So we recently introduced the option of having 400 gig ports to members. We're one of the first exchanges in the world to do so. As LINX is a large exchange relative to numbers of AS and traffic throughput that we have, it was just a next step for us. And so we worked together on this with our chosen partner, Nokia, which we'll go through in the slides and talk to you about how we came to that conclusion. So we're going to talk about the various developments and the complexities around it, and obviously the process of how we achieved the decision-making stance that we took. Just a little bit about LINX and who we are, what we do. So London Internet Exchange, for those of you who don't know, we're one of the largest exchanges in the world. Established in 1994, we're a non-profit internet exchange point. We have many members ranging from research networks, all the major cloud CDN providers, ISPs, from far and wide, from all over the globe connecting into us. Just a little bit on the numbers point of view. So as I said, we have members far and wide, so 887 as of last August's count. 82 countries overall that we have members from. So that's a mixture of LINX having our own direct POPs and also reseller partners connecting into London. A majority of that is through our reseller partners that we utilize. We're just about under 50 terabits of traffic with a shade under 1,000 AS numbers connecting into the exchange point. So today's topics, well, why 400 gig and why the solution matters, the key objectives in reaching that, pandemic delays, which are always fun, and the decision-making process behind it. We'll touch on new vendor options, the evaluation steps, the closing stages, and talk about the future plans as well that we have for 400 gig. So why 400 gig? Why not just lag a bunch of 100 gig ports together? Well, we wanted to identify a long-term solution for higher density ports at a lower cost point, which is the biggest challenge for everyone in this room. Everyone wants scalable ports at lower cost points, regardless if you're in Tokyo, Africa, or London, wherever it may be. Everyone has the same challenge. So we believe that 400 gigs helps us achieve this. So our most significant exchange is obviously London 1. We operate 2 exchanges in London, London 1, London 2. London 1 is our primary LAN. We converted this from an MPLS, VPLS network to MPLS EVPN network. We've had to prove out that a large-scale EVPN network on a multi-vendor solution approach would work for 400 gigs. So it's a couple of things that we had to consider. Also, other IXPs, network designers, data center fabric operators, anyone that runs a large size network would probably be interested in hearing what we have to say today about 400 gig. It's the next feasible step from what we could see from having, instead of multiple 100 gigs, the next step up from that. So we're in the early adoption curve from it. We'll touch a bit on what we've learned with working with a mixed vendor solution. As you must have heard today, someone asked Nurani about it earlier, about our LON2 solution that we have, which is a mixed vendor solution on LON2 with the hardware and the software elements being provided by 2 different companies. And we'll also touch on how this can benefit others in the room, and how hopefully you'll also be able to adapt to 400 gig should your network require it. So the key objectives, the research phase and the viability of 400 gig. So as I mentioned, the key objective for us is to find a long-term high-density solution that would integrate with our current network, as well as the automation tools. That was the biggest challenge that we had. Because we've done a lot of background work in automation and we didn't want that to go to waste. So it was important that we could find something that would fit into this current solutions that we have in regards to automation. It had to be capable of being able to integrate an EVPN network. That was one of the must-haves that we had on our tick list. And also be able to adapt to the portfolio of products that we have. So cloud, closed user groups, etc. That was one of the key metrics that we had for us. The fun of having pandemic delays and the impact of COVID, which obviously everyone in this room is touched by in some shape or form. So when the lockdown started, we were just at the initial stages of evaluating the new technologies that we could use for 400 gig. Little did we know the road to come. As of March 11th, 2020, all of the LINX staff started to work from home. 23rd of March, the official UK lockdown began. And during the summer, it just got heightened to various travel restrictions, etc., which also led to, obviously, us not being able to do a proof of concept we had hoped for originally with various vendors. So our engineering team couldn't travel out far and wide to test this in a lab environment. So we had no firm dates in close sight at all. I don't know for others in the room, but from the UK point of view, it wasn't clear at all. We were just living on a day-by-day basis as to when the travel rules would be updated. So obviously our engineering colleagues could not plan ahead. This had a big effect on how we could look at planning out a network. So after 2 months of video calls, remote presentations, lots of throwing back over Zoom, we had a clearer picture of the landscape as such that enabled us to answer all of the big questions that we had and at least start on a testing phase. Decision time. So obviously there came a point where we looked at all the options available and then had to come to the decision of who we choose and why. So for us, at the time, Juniper did not have a high density solution from our MX960s. Our only option at the time for Juniper was to wait for 24 months for a high density card for the MX10K routers. And that wasn't a feasible idea for us because obviously we were hopeful to roll out 400 gig as soon as possible on the exchange due to member demand. So waiting 2 years wasn't really an option. Edge core networks and IP infusion. Why not take the same vendor that we use on LON2 onto LON1 and deploy a 400 gig model there? That's a good question for ourselves that we deliberated with quite a bit. The main reason of having 2 diverse networks, so London is run on Juniper and London 2 on edge core networks and IP infusion. And that's to add extra resilience to the LINX peering lens for our members. And we thought if we bring edge core networks edge core IP Infusion onto LON 1, this drops our rate of resilience down considerably. So it's not something that we would want to do for our members, because it's not in our members' best interest. So that was a kind of a hard no there on that. And also there were some issues on aside from the resilience side, just the OCNOS had not been ported as well for mesh migration cycles on the network. So that would also prolong us even more into making that decision. So that just didn't work out for us. So the most suitable vendor options that we had were Nokia and Arista. Arista did actually offer the highest port density for us. They already have a driver for us to use, and it was a great user base. Unfortunately, they weren't able to support VPLS and Ethernet OAM network. So that was, of course, for concern on us. On that basis, we couldn't opt for Arista because it didn't fit into the current model that we were looking for. Lastly, we looked at Nokia. Nokia supported OAM and VPLS, so that takes both of the boxes there for us. They had good port density and were highly competitive in terms of pricing. Then we had an extra comfort factor that France AX and DKIX also use Nokia. DKIX runs on a large 7750 SR deployment, so that gave us some comfort in knowing that if we did deploy it in our primary line in London, that we were in good hands. So obviously testing and reevaluation. We did a lot of testing in between this process of the start of 2020 and rolling up to now, towards the end of 2021. So the steps that you can see there, due to the uncertainty of obviously the marketplace, COVID, et cetera, and all these other factors that were implemented, travel and things like that, that we couldn't do, testing had to wait till 2021. We didn't really get a chance to get our hands on in a lab on the equipment until that time. But we were doing as much as we could over Zoom. So Q3 2022, we made the decision to use Nokia for general deployment. And then we've done some various testing on our own on SR2s. We've done a hitless migration from VPS to eBPN with Juniper, so we were able to complete that as well at Q4 2020. So these are just some of the steps that we had to go through to get to that. Supply chain issues. Now, this was a fun part, as everyone also knows that supply chain is a big problem now and still is, right, in today's modern chip shortage world. This obviously impacted us heavily in not being able to get the various routers and switches that we need. There's shortages in the silicone market, ranging not just for routers and switches, but cars and everything, other type of appliance. I'm sure if you ordered something over Amazon now, you're facing the same kind of delays for larger technology heavy goods. We started on testing on Juniper at the time as well, just as a resilient backup. The MPC 10 cards for the MX 960 for low density sites, that offered us some various features at testing. We were able to accommodate a combination of up to 10 or 1500 gig ports on those that could be repurposed, and a selection of 2 to 3 400 gig ports on there. So we decided to test the SR7s as a fully integrated EVPN MPE. We were confident that Nokia was the vendor for us at that time, and proceeded along with the testing. Closing stages, including rollouts. So the timeout for rollout, as I mentioned earlier, we started at March 2020, and then going all the way from March 2020 to Q3, August 2021. This was the whole cycle that it took to really deploy 400 gig on our network. That's when we received the equipment in August. We did further testing September 2021. In October 2021, we were able to put the proof of concept into play and start taking orders. So further testing, October 2021, MPCN 10 in Juniper Labs, a 6-week deployment of SR7s. And then actually it was November that we started taking orders. We did take orders a little bit before then, as we had to notify, we were speaking to our larger members that we knew had that appetite for 400 gig. So they were ready and eager to place those orders at the time. 400 gig is currently deployed. It's Telehouse, which is the founding spot of LINX. It's available at Telehouse North. We can actually serve the entire Telehouse campus if there is a requirement for that. And also Equinix LD8. Future plans for deployment. We're very happy to deploy 400 gig anywhere where there is a demand. So if there is a demand for any networks out there that is looking for 400 gig, please do let me know. Or speak to the team outside in the foyer. We'll be happy to talk more about it. If there is a site in London or the UK or any LINX site that we're operational at, we're happy to look at that option. But for now, depending on the member demand, we're looking at Equinix Slough and Interaction Brick Lane. The type of optical interfaces that we're currently supporting on 400 gig, and I'm rolling up now, are the LR8s and FR4s. We're going to look at other versions after October, when we'll be able to support more vendors on the system. We're hoping to add LR4 on there, which would be cheaper for optical interfaces for us and our members. And I'll just touch on this and slowly wrap up. But the first 400 gig connection was Core Backbone. November 25th that they placed the order. So they went live with that, which we're very happy to say. They worked with us as one of the first networks to join on 400 gig. So there's a lot of going back and forth with the peering managers and the engineering team there, but we managed to do it successfully and migrate across their existing 100 gig traffic onto the 400 gig solution. And that's just a quote there from the head of sales and marketing for Core Backbone. I think they're happy with the solution and it works well for both parties. The future plans is obviously to roll it out, as I mentioned earlier, to all across the LINX sites and anywhere that there is an interest that's member driven. I'll skip across these in the essence of saving time. If you'd like to learn more, please reach out to myself at the email below, or any of us here from the LINX team would be happy to talk about it. Any questions, or are we over time for that?
Thank you very much, first of all. And I will start by taking questions from the floor.
Sure.
Any questions from the floor before we jump into the online Q&A? No questions from the floor. Do we have any questions?
We have one up here.
There is one from the floor.
We got the
Mike. Is it working?
Could we get a spare mic or something? No.
We can use the oh, yeah, maybe it's working.
And I hate being on the spotlights. All right, Jonathan, Plumber Technology. So we specialize in hardware, so networking hardware. So for me, it was interesting because do you think that the SR7750 is going to be like a trending over what Juniper is doing, or Arista? Was that something just because, I mean, the specs of that equipment was just adapted for LINX?
So yeah, that's a very interesting point. Firstly, I'd like to point out I'm not an engineer, so I'd like to give that caveat first. But the reason we opted for the SR7 is that the availability time-wise, Nokia could fulfill that. As I mentioned in the slide, Juniper, we're looking at around about 18 months to 2 years for a deployment. Same with Arista as well. So it was more so not anything against the aforementioned names, but it was just a timeline issue that we had, and Nokia fulfilled that for us. So we were able to go with them.
And from a costing point of view, I mean, was it about the same on the budget side or?
I believe so. I mean, our engineer, one of our engineers is also here. We could have a chat with that. The link stand for you on that.
Thank
I
you.
do know it's a time deployment issue, more so that we went with Nokia as a vendor.
Understood. Thank you.
Thank you.
Questions from the floor? And if not, can someone check whether we have some online questions? Oh, no questions.
Excellent.
Thank you.
Thank you.
So, thanks, LINX, to guide us through the road of 400G. Our next speaker is Josiah, and he will guide us through the measuring cloud latency in Africa. He's from the University of Cape Town, so welcome. And we are here to hear you. 20 minutes.
Hello. Right, thank you. So my name is Josiah Chavula. I'm at the University of Cape Town, so I do mostly academic research. So what I'm going to be presenting here is some of the work that I and some of my students have been working on, basically to try and map or sort of understand what the performance of access to cloud-based infrastructure is like. Okay, so University of Cape Town, in Cape Town, obviously. I think I heard from a number of you that you'll be attending SAFNOG, so you're welcome to Cape Town. I'll be there to show you around if that will be your first time there. So my work there, research-wise, involves mostly doing measurements on the internet performance, particularly in Africa. That's been my interest and my work. I focus quite a bit on quality of service, quality of experience for low resource networks. So I do a bit of work in community networks as well in Cape Town and other places. And in general, just measuring performance or properties of the internet in Africa. So the cloud in Africa. Okay, so we've been hearing and we've been talking about the deployment of cloud data centers and so on. And some of the recent work that we've done trying to measure performance or utilization, we've seen that most of users or clients, at least accessing CDN-based content or cloud-based content from Africa, they are being directed to CDN nodes that are in North America and in Europe and in Asia, probably. Okay, so this is part of the work that I'm going to show you. This is what's still the case. Whether that is because we don't have a lot of CDN nodes in Africa, or it's because of latency and connection, and therefore we're being connected to other places, that's something that we can look at. And of course, just comparing latency for users in Africa accessing CDN nodes versus those that are in Europe, just comparing the latency is what we're trying to do. Okay, so just if you're going to take anything from this is that most of the users in Africa are being directed to CDN nodes outside of Africa. That's well known, but the extent of it is actually still alarming, and the latency is much, much higher than other places. Right, so obviously, when we talk of cloud, we talk about the data centers that have been talked about here. I think Nigeria is trying to deploy many of them from the discussions that we just had. I think from at least my understanding of the public cloud in Africa, the major data centers that are there that you can use are the ones that are in Cape Town and Joburg. And it's usually, or it's mostly Amazon AWS and Microsoft Azure that have these data centers where you can actually run your virtual servers from. And so they call these the regions. So they have regions in Cape Town or in Joburg. And Google doesn't have any region. And then the other thing that we also been looking at is just looking at the points of presence for where cloud providers would host their content delivery service or nodes where people would access content if it's provided via that CDN infrastructure. So we, again, looking at the major providers, we see that most of the CDN POPs or points of presence are in Cape Town, Joburg, in Nairobi, in Lagos, in Mombasa. And then Cloudflare. Cloudflare seems to have the most number of POPs that we could observe in Africa, 21 of them. Okay, so those are the things that we will be using for our sort of study. Okay, so maybe just again to refresh, maybe for those that may not be too familiar with how these CDN nodes are utilized from the perspective of users. Normally, these cloud providers would redirect or direct the clients or users that are trying to access content based on, let's say, geography. So geography redirection. So using the location of the user to determine which CDN node to forward them to. But sometimes and this normally uses the DNS resolver. So if the client is using a DNS resolver that's extended from their geography, then obviously they're going to be redirected to, again, probably a remote node. Or maybe if the geolocation itself is just inaccurate, again, they're going to be redirected to a different place. And also geographically close nodes or servers are not necessarily the lowest or they do not necessarily have lower latency. Sometimes they have higher latency. So it doesn't always work out well. And there's also latency-based DNS redirection where the latency between the DNS resolver and the available CDN is basically used to determine which CDN node to send the client to. So these are the two things that are going to play a role in what we're going to observe in our data. And then, of course, there are others that use anycast, where the same prefix is pronounced from multiple places, and then the user gets redirected. Again, now this is based on how the networks are interconnected, where they're peeling from, and whichever of those anycast addresses seems closest to the user. All right, so the question that we were trying to sort of understand in this case is which are the CDN nodes or POPs that users in Africa are directed to mostly, and what are the delays for African users or African nodes clients when they access these CDN POPs or CDN data, cloud data centers, and how do these characteristics differ when you compare with other regions? Okay, so we did a bit of a study there. So we launched a sort of a cloud application, a web application, and launched it on these 4 cloud providers. So we launched the same application on AWS, on Microsoft Azure, on Google Cloud, and on Cloudflare. Okay, so it's the same application, just launched it on those different platforms. And we wanted to see if we are trying to access this web application from different parts of Africa, where are we going to be directed to? Okay, so that's what we did. And then we used RIPE address. So we identified about 71 RIPE address probes from 17 African countries and used those as our vantage points to access these web applications. And we did the same for some from Europe as well. We identified some vantage points from Europe, about 58 RIPE address probes. And then we ran ping and route trace route measurements for about 30 days. Okay, so that's just to collect the data that we needed to understand what was happening. So maybe let me just mention here. So having run that, we tried to identify the IP addresses that the clients were being directed to. So when we're trying to access this web application, obviously there's the DNS process that happens, and then we have the IP address. So we wanted to see that IP address and if we could geolocate it. Okay, so we had over 300, close to 400 unique IP addresses that we were able to find from the data set as the end nodes of the CDN points or CDN servers that we're servicing or responding, providing content to our vantage points. So we realized that Google and Cloudflare were using Anycast. So the IP address was the same. So it didn't really work out for us when we tried to geolocate it. So we put that aside. It didn't help us in terms of the analysis that I'm just going to talk about. But we were able to use the data from AWS and Cloudflare, because we saw that they use DNS-based redirection. So if we do a reverse DNS lookup, we're able to identify the specific servers that were assigned to those IP addresses. So we use this reverse DNS lookup info by IP, basically just to do that resolution lookup. And then we were able to see that the results that we're getting have these unique city codes, the IATA city codes that are identifying where the servers are located. So we use that as a way of sort of inferring where these particular servers are located. So that's the analysis that we did. Okay, so we were able to sort of infer where these IP addresses are and where these servers are. Okay, so having done that, we were able to say, look at of that 300 IP addresses, the unique IP addresses that we had. For AWS, we saw that about 95% of them, the IP addresses, when we did the reverse DNS, pointed to servers that were located in cities in Europe or in North America. Okay, so those are the cities listed there. They mostly in Europe, and those are the countries. The only ones that we saw being based in Africa were in South Africa and in Kenya. So that's the only place where we saw nodes that were actually responding for our queries. Okay, so basically that's the scenario. Most of the CDN nodes that would be responding were actually in those places. We did the same for Microsoft Azure. The result is almost the same. We had about 20 unique IP addresses for Microsoft Azure. Only about 2 IP addresses resolved to servers that were located in Africa. I think one in Egypt and another one in Nigeria. The rest were in Europe. So again, that's just to say this is where the users get redirected. So that gives us some idea. Of course, this is just based on the IP addresses. It might be that maybe many of the users in Africa would be directed to the same few IP addresses that are in Africa. So it doesn't necessarily map exactly to the volumes of traffic. I'm hoping that some ISP will be willing to work with us to be able to actually look at the volumes of traffic that gets sent to these IP addresses. But if you just look at the number of IP addresses, that's basically the distribution. And then we looked at the latency just to compare those different cloud providers, the CDNs. We had the Cloudflare, we had Azure, we had AWS, we had Google Cloud. And we saw that from the African vantage points, the lowest latency would be the one that we would get from Google Cloud, a median latency of 29 milliseconds, going up all the way to Cloudflare, which was at the median of 65 milliseconds. Of course, that was a bit strange because, as I said, Cloudflare has the most points of presence that we observed in Africa, but also they had the higher latency. But again, I would understand that because it doesn't mean that because they're geographically closer, it means the latency is necessarily lower. It might be because we have many more higher latency paths within Africa. So you use more of the African POPs, you also experience a little bit higher latency than those that are actually being sent to Europe and other places. Okay, so that's basically the range of median latencies that we observe. And then South Africa and Morocco and Kenya had the lowest median latencies. Again, you'd expect that because I said that's where we saw those points of presence or CDN POPs that were actually responding for our queries or for our mobile app or web app. So the range of delay there was from 5 to 10 milliseconds, which was much, much better comparing to the others. So the highest ones that we saw were in Burundi, Cameroon, Madagascar. Their latencies ranging above 100 milliseconds, 150 to 200 milliseconds. So that is much higher in comparison. But of course, the other countries also, they have some that are lower, like under 100, but you've got all these outliers that are also going way above 150 milliseconds to access the CDN nodes. And then just to compare in Europe, because we did the similar study, but I'm not focusing so much on the analysis from that side, the latency there was ranging mostly from 12 to about 15 milliseconds. That's the lower end of it. In France, Germany, and UK, that's the range that we saw. The highest was observed from Russia with about 33 milliseconds as the sort of median value. Okay, but in terms of comparing those cloud providers, the range was the same. In many cases, Google Cloud provided lower latency or the lowest latency, and Cloudflare was a little bit higher. And then we did a little bit of comparison just to compare what happens when you actually accessing directly the data center versus when you're accessing the CDN nodes or the points of presence. And we saw that if you're accessing directly the data center, like the AWS one from Africa, the median latencies that we observed was around 84 milliseconds. That is higher than the 45 milliseconds that we observe when you're accessing the CDN nodes. So obviously, if content is being saved via the CDN infrastructure, is that improvement compared to when you are being serviced directly from a data center. And of course, for Azure, the latency to their region was 74 milliseconds median. Again, that is higher than the delay to their CDN nodes. Right, so just if we look at we compare just the improvements there, we see that the African countries with the CDN presence experienced lower latency between 5 and 10, as I said earlier on, and the latencies to CDN endpoints were lower than the data centers. So there is that improvement in performance if the content or the services is provided via this CDN infrastructure. So just mentioned there, so the improvement was around 87% for AWS and 25% for Azure. And in Europe also, we saw the same. If you're accessing the data center, slightly higher latency than when you are accessing the CDN points of presence. Actually, for AWS CDN, the performance difference was much higher, over 142% performance advantage of the CDN infrastructure. Right, so that's basically some of the results that we show or observed. So the observation there we have is that the most or the really significant majority of the CDN points that are being used by African endpoints are outside the continent. And then we saw that in some cases, the CDN locations in South Africa and Kenya were present, but we still saw in some cases in those countries, we had CDN results that showed that the client was being sent to somewhere else outside the country. Okay, and of course, Google Cloud showed the least latency. It uses Anycast. We couldn't do the geolocation that we wanted to do, but it does provide the lowest latency from those that we compared. Okay, so obviously better performance with the CDN points of presence. Hopefully we need to get more of that. The performance issue, I don't know whether it's a peeling issue that we've got points of presence, but the performance is still sometimes not as good. Is it that we don't have enough points of presence, or is it just that we're not well interconnected and therefore we're being sent to the other places to access content or services from there? Right, thank you. I'll be glad to get some feedback from the ISPs and operators of these networks or questions. Thank you.
Just checking whether there are, first of all, Josiah, and checking if there are any questions from the floor. There is one over there. Sorry, Nuran, it's killing me. Go ahead, Nuran.
So, Nuran Enupuna from LINX. Fantastic presentation. Thank you so much. It was really interesting. It'd be very interesting to dig a little bit deeper into those statistics, but I think this type of research is really interesting. And you know, it's exactly the type of measurements that we need to also understand, you know, how can we improve interconnectivity in Africa? Yesterday at the AFIX meeting, we were talking about, you know, what ISOC's work about supporting this. So these types of measurements, I think, fits very nicely into that. So I was just wondering also if this is something you intend to continue with and compare over time, because that would be really interesting to see if this is something that improves over time, and you know, what factors come into play to change those numbers that you've shown. Thanks a lot.
Thank you so much for that compliment. Yes, so this is the work that we're continuing to do. We're collecting data. Some of the apps or the cloud app that we talked about are still running. We're still collecting data. So hopefully we will have something to report on in the next and the next and the next and compare. But yeah, we have students that are interested to do these types of research. The challenge is that sometimes students that are doing academic research don't come to forums like this because they don't have the opportunity to come. But I think this is where they need to come and really experience and hear from the operators, what are the challenges, what are the things that are actually happening. Like the question that I asked you earlier about what are the issues that like affect or inhibit peeling? Is it just the data access or is it something else? But I'm happy to have more conversation with you in terms of how we can work together and support the work of collecting data for this type of analysis.
Yeah, more than happy to continue the discussion. So thanks so much. And also, if there are, you know, areas that are underserved for the probes, maybe this is also a good venue to actually evangelize that a little bit.
Yes.
Thanks a lot.
Thank you so much.
Ooh. Hey there. Good afternoon. Ben Ryle, Meta. Excellent presentation. Super interesting. Lovely use of RIPE Atlas. Just wondered, and this is a slightly loaded question, so apologies. Just wondered if you had any plans to extend it to other CDNs that maybe don't have a cloud offering, i.e. Meta.
Well, there is always scope, and we are super interested to do more. Because obviously this is a limited study. We only had these 4. And also we didn't analyze the geolocation for Google, for example, and so on because of the Anycast approach. We need to figure out another way of figuring how users are being redirected in that scenario. But again, this is work that we are continuing, and the reason why I came here is basically to talk to people like you to say, how can we do this? What can we do? What could be useful for the community in terms of the academic work that we do?
Yeah, sure. Thank you. Super happy to help and contribute how we can. Let's link up. Thanks.
Yeah, thank you so much. Oh, there's a question.
Yeah, thanks, Josiah, for a good presentation. Just to add a little extra work to what you're doing, can you please try to find out from the upstream providers of the locations where you're probing from, what kind of pairings they have with the CDN operators, to know if there's like any direct connections or if they're relying on upstream provider fabric to get to the CDN. It will also help improve the insights.
Yes.
Thank you, though.
Okay, thank you so much. Yeah, I'll definitely try and do that. If anyone is interested in more academic research or they want to do research, they particularly based in Africa, I'm happy again to have conversations with you.
So I'm going to read the first one, and then I'm going to hand over to you. So we had one question from Anok. I was trying to figure out which slide that was, but he's saying, under what scenario would geographically closed servers have high latencies?
Yeah, so if geographical, so we had, okay, maybe I didn't get into that. So for example, there was a scenario in Botswana where a node or one of our vantage points was directed to a point of presence in South Africa. But the path that traffic was taking was actually going to I think it was London. There was a really circuitous path going all the way to Europe and coming back to Cape Town. So in that case, even though you're geographically close, but if you don't have a proper path between your ISP and where the CDN is hosted, then you're going to have this sort of high latency, even though you're geographically close. So again, that's where peeling and interconnection becomes important. It's not just having the points of presence, but making sure that the ISPs, CDNs are well interconnected so that geography gives you the advantage of low latency. Otherwise, it doesn't.
One more question. Very good presentation, by the way. Another question is from Andre Arnold, and it goes by, how do you think the different exchanges can support in reducing the latencies within the continent? How do you think the different exchange points, I guess, can support in reducing the latencies within the continent?
I don't know if that's a question that I could answer. I think we've got the all the exchange internet exchange point IXP players here, peering, interconnection. I think that's what we're looking for. So more peering, more, I don't know whether it's open peering, whatever it is, but as long as we get more interconnection, the latencies go down. If we don't have strong interconnection, we're going to have these circuitous routes going outside the continent and coming back. And even though we have points of presence, we're not going to get the advantage of that because we're using circuitous routes. So circuitous routes have to be really significantly cut down so that we get the advantage of having points of presence in the continent.
Running out of time, but I will give the shot Ben to raise the last question, please, and then we cut it off. Otherwise, we're going to spend a lot of time in it.
Yeah, so the benefits of exchange points is well known. When we've looked at these types of things before, we see that a lot of the problems is either the ISPs are actually running long lines to London still, and not, even though they might have, some presence in peering in Africa, they're running their main feed links to London, not to South Africa or Nairobi, where you've got CDNs. But we often find as well that they're just not configuring the BGP properly, right? They're not peering with the CDNs. They're not routing the right communities to say, this is my prefixes. So the CDNs don't know where they are. So they're just serving them from the wrong place. So how do we educate ISPs whose customers are suffering because of this, that they don't know how to do their BGP properly? They don't want to do it right.
Thanks, Ben, for this one. I don't think you expect a reply in here, right? It's more, thank you. Yeah, thank you. Thanks a lot. And a round of applause. So apologize for that. We are running out of time, but it was an interesting topic. The next speaker, I would like to call Jean-Baptiste, and we will guide us through the 50-50 vision of the internet in Africa. JB, sir. That's 10 minutes.
Hello, everyone. So, okay, I'm Jean-Baptiste Millogo. I'm from Internet Society. My daily work is to support development of IXP across the continent. I'm also working to support development of any community network and also supporting any kind of network operator group. It can be NRN and everything relating to that at Internet Society. My talk today is to share with you, let me say, an update on what we've done those past 10 years regarding the vision we call 80-20, and check with the community what can be the way forward for the next coming years. In terms, as agenda, I will share with you a kind of update on the lesson learned from the last vision, and also share with you a kind of methodology or approach we think that we can maybe engage community to go forward in Africa. And we also up that we'll get some comment and feedback from the community currently here, based on the update we have shared, and also in the future through AFIX mailing list or AfPIF mailing list. So basically, from 2010 to now, we have all run a vision here. It was not formal, but what we got from this vision is that our expectation was to keep around 50% of traffic in any country in Africa. But at the end of this period, what we observed that only 3 countries was able to achieve this vision. It's essentially Nigeria, Kenya, and South Africa. And despite, I will say, several development, several contribution of many stakeholders in the community. And the achievement was a little bit different, and you can see in the table here that from 2010 to 2020, we moved from 18 exchange points to 46, and most of the country, as I was saying, has under 70% of traffic locally, and in 2010, there was no data available to measure the number of network available at IXP, but we got 10 in Nigeria, Kenya, and South Africa, and maybe Tanzania, and also Uganda. And we also noticed that from 2010 to now to 2020, there was no data also available regarding CDN connectivity in our region. I think what Josiah was showing could permit, I think, now to improve that and to have more visibility on what is happening in our region. At the end, we try to summarize all those those observations in the report, and you can find the global report in the QR code I have put here. So, from what we are expecting to have with this 2020 vision, we understand that result was not good everywhere. We understand that it could be good to have more network available, more, let me say, route available in the interconnection facility across Africa. We also understand that we need also to improve, let me say, the operational of any exchange point or interconnection facility in Africa. And for that, we need a need of, let me say, all stakeholders. Can be IT, can be regulator, it can be network operator, and we'll build and this way a new vision which would permit to improve acceptability or development of internet across Africa. So in that way, we think that we need first to improve the number of network, because if you have more network available in the exchange point, that means that we'll be able to keep locally more traffic and to serve to share better experience to all customers. And we think also that this vision needs, if we want to achieve it, we need to have, I will say, a formal but a good engagement of community, because each of stakeholders need to contribute, even if technical side or regulation side. And for that, we need your help, we need your contribution, we need your feedback on how we can achieve this new challenge together. So, as IXP, because I think there is many IXP operator in the room, we think that we'll need your contribution by increasing the capacity of your members, your peers in your respective country. We think also that we'll need to have a kind of community contribution, community experience sharing through national event, regional event, or kind of continental event like AfPIF, because it's a kind of opportunity to share together what is working in maybe in some country and impact the others. And at the end, we think that if we are able to attract 50% of ASN, African ASN in each country, it can be something which is impact significantly what is happening in our continent currently, and then improve the experience of global access in the continent. So, for the other stakeholders, I would say government, CDN provider, because we have most of them here. We need also from them to have a kind of advocacy, because sometimes regulation can be a kind of bullet point in some country, especially in Africa here. there is some I will say, some no development of internet due to the regulation issue in some geography. We'll also need maybe I will say more or improve the cooperation between all stockholders, because sometimes it's not easier in some area. And I have seen here today that in some country, I would take the case of Nigeria, most of stockholders coming, how they can work together and contribute to have a better connectivity instead of maybe a competition. I think they need to work together. So at the end, we think also that we need to improve in the continent the development of more carrier data center, because we need this kind of facility to develop internet in the continent. So how you can contribute to design this vision with us. So we think that from today, maybe we can collect some hot comments, some hot feedback. And from September, we will share through AFIX mailing list and also AFRINIC mailing list and AfPIF mailing list what we think about this vision, and collect again your comment. And by end of year, we'll have a kind of new draft. And we think that from next year, we can start executing the new vision in any country and for the next 3 years. And we think that it can be something which can improve how internet is delivered today in Africa. So I think that's all for me. So feel free to ask questions here or after, and I will be happy to have you in our team and contribute to have a better internet in Africa. So thanks.
Thanks a lot, JB. Definitely, I guess if anyone has questions, please just go one-on-one with JB, engage with him, because we are running out of time and we still have to. Apologize for that. JB, once again, thank you very much. Very good job. Our next speaker is Eugene, and he will guide us through the measuring internet in Africa. Eugene is from Oracle Labs. Welcome. No? From the website, I guess. Yeah, go ahead. Please, yours.
I'll try. Hello, my name is Eugene Bogomazov, and today I want to present you some results after we would take a measurement of some of the networks of African countries, and want to share what we were trying to measure, what are the results, and what you can do, what conclusions we will make after seeing these results. First of all, why do we care? I'm working for Qrator Labs. It's the DOS mitigation company, and we have our own BGP NICAS network. And I present radar projects. We have at radar project our own BGP collector with more than 800 points of presence. So we have a BGP data to create a BGP monitoring tool, and also to use this BGP data to use in different network researches. Also, as a part of radar team, we take a part in a ITF activity and trying to make a BGP protocol more secure and safer. And I'm a little bit curious, could you raise hands of those who have heard about our company, about our monitoring tool, and so on? Okay, thank you. Interesting results. Okay, what I'll try to tell you in the nearest 15 minutes. First of all, we will talk about what our measurements are, how we measure, what we are trying to measure, how we will present it, and so on. Then we will take a look at some simple but powerful metrics that we found out. Then we will take a look at the specific metric about how stable is a network region in case of single point of failure. And then we will take a look at some of the BGP incidents, in particular, how often your address space is violated by BGP hijackers. And lastly, we try to find out what are the main differences which happened in IPv6 world. But first things first, and let's talk about what we're trying to measure. Each measurement consists of separate parts. First of all, we will discuss what data sources we use. Secondly, we will discuss what algorithm we are using and what are the pitfalls that can happen in it. And also we will provide the results of these pitfalls. And secondly, and lastly, we will visualize our findings. And as I was mentioned, we have our own BGP collector. And these are, on this map, you can see all of our points of presence. And if we have BGP data, we can make conclusions, make a research, and so on. And I think you see a little problem with this map. Even if we have several hundreds of BGP sessions, in Africa, we have only 15 points of presence. What is the problem? In Africa, there are around 50 IXPs, and there are a lot of local routes that can be seen only on these IXs and don't traverse to the tier 1 and to different parts of the world. And so we don't see this kind of route. We don't see the local peering, and we don't take in consideration these peering links if we are talking about local connectivity and so on. But we must use what we have, and for this presentation, we will use our data from other parts of the world. Also, when we are talking about BGP data, we see prefixes, size buses, and so on. So to get description about ISNs, we use whois databases. To get geo information about to which country given ISN or prefix belongs, we use geo community services such as MaxMind and so on. And when we are talking about prefix violations, there are two types of objects about legitimate owners of address spaces. This is Afrinic IRR for route objects and RPKI storage for RPKI row objects. And when we're talking about rankings, we have a problem. Because network is a graph, there are too many ways to try to find out which nodes of this graph are important. And so we need to find a subset of these metrics that are, from one point of view, are simple enough, but from our point of view, are powerful enough to describe what is happening with the region in a whole. So we'll, for the first part of our presentation, we'll take a look at the most common ones, and then we will present our own metrics and try to describe what they're trying to measure and why they are important. So let's take a look at general metrics. When we are talking about what happened in the region, the first thing that came to the mind is how many ISPs are there in this country or region. And there are, you can take on this metric into different angles. First of all, you can try to find out how many ISNs are registered in your Afrinic IRR, or for example, you can also BGP routes find out how many of these ISPs are trying to announce their prefixes and thus find out what part of the ISPs are currently still alive. And when we are trying to take a look at the results, we found out that yes, South Africa, Nigeria, and Kenya came to the top with a huge lead. And we have already heard on this conference why it's so, because they have a growth market and there are many operators that were created in the last years, and we're trying to provide the services in these countries. But there are 54 countries total to display. So we need to decide watch subset of the results we need to display. And for the rest of this presentation, we will discuss the countries that take a top places or some kind of median placement, which will highlight how the region is fallen into given metric. And also, I want to highlight that these top 3 countries have more than half of all the ISPs in the region. So when something happens with these countries, it can affect the region in a whole and even a metric of the whole continent. Okay, we take a look at the number of ISPs, but ISPs can be different and take a different part in total life. First of all, you as an operator can create your ISN to provide local service to your local customers, for example, banks, universities, and so on. So you need to just buy a prefix, announce it, and doesn't care about how the network is operated. And there are another part, namely transit network, that try to connect these local operators to the rest of the network. And if we take a look at the pie chart, we find out that first type of the operators are the most common ones. They take 3/4 of the all active ISPs. So the number of operators that provide a transit is quite small, but they take a huge part in internet health in the total. Okay, but who are the biggest transit operators on the continent? Of course, we must name some of the tier ones. It's Cogent with a huge lead, then Tele and Level 3. But we cannot name only tier ones. There is a big tier 2 operators that interconnect region in a whole, and they cannot be mentioned by consumer and other similar metrics. So we need to design our own metrics that will highlight them and highlight how important are they to the region. So we will make 2 assumptions. First, we will consider all of the cents of the country as equal, and they will have an equal weight. And second assumption is that transit provider equally distributed all of his weight to outgoing provider sessions. So everything is equal, providers are equal, and this is simple enough. And now let's dive into what result these assumptions gave us. Of course, on South Africa and Southern Africa region and East Africa region, we will see CCOM, which provide cables and so on, liquid technologies that are quite often take a participant on AfPIF, and West Indian Ocean Company. On the West, main one take a lead with a Dolphin Telecom. And for the North and Central part of Africa, there is a quite interesting situation. Because Egypt and Cameroon is a big part of North and Central region, correspondingly, the biggest transit operator of this country became the biggest transit operator of the given region. And what about other countries? Mostly of African countries have 10 or less active ISPs. And this is why you can always find one transit operator that will control more than half of the whole traffic of this country. And the most notable exceptions are Egypt and Angola with Angola cables. And on the other part, there are Seychelles in which ISPs are directly connected to the tier ones, and no one of the Seychelles ISPs has more than 10% of country traffic control. Okay, and what will happen with these TIS and global cables if they went offline? How stable will the remaining of region be? for this, we created our own metric and modelize exactly this situation. There are some discoveries that we created during the several years that we created this type of analytics. And as expected, countries that were trying to create and grow the local respondent local markets are in the top places, such as Seychelles, top 3 African markets, and Mauritius. And as for Egypt and Angola, this kind of control of the country traffic results that huge part of the region will be cut off of the internet if GIS or Angola cables will go offline. Okay, if you talk about prefix violation and hijacks, there are 2 types of legitimate objects which we must consider. It's route objects and raw objects. They can give you different validation status of the routes based on this information. And it's common practice to drop invalid routes. And if you take a look at what happens in Africa, we can find out that the number of raw invalid routes is bigger than in all the other countries in total. But if we take out South Africa from the equation, it will remain relatively low. What's happened? Most of the routes which are hijacked are stay local because of different conditions, BGP optimizers, human error, and so on. And if we filter these routes out, we will receive or might highly bright picture, and this type of analytics we will count on, and we will see that currently around 20% of routes are currently sited with raw objects. It's good enough, but it's still not high enough as in the rest of the world. So there are several problems with the hijacks. So you need to scrap the data and so on to have a real results. And if you talk about IPv6 adoption rate, only 1/3 of all the ISPs are currently trying to provide IPv6 services. Of course, in the top are the countries that we are expected to, and we can find out that Africa, it's not important. Okay, this is some of the results for these countries. And if we highlight the main difference, the main IPv6 tier 1 provider changed from Cogent to Hurricane Electric because it tried to be in every IX and to be present as wide as possible. And also, if you're trying to be on IPv6 world, you're trying to create more providers, and this is why big players take a less control of the flow that travels through there, because it created a high diversity. And as final remarks, we want in future to add different type of analysis to highlight local features such as huge presence on IXPs, the difference that created by a coastline and the landlocked countries. And we want to include your ISP knowledge of the region in our future region overviews. So if you have a question about what is going on, what is your position, if they are not in the charts, or you can have a suggestions about what can be improved on what you want us to be measured, you can find out me here, ask questions, and so on. I will be very glad to see and hear your impact on this topic. Thanks, questions.
Thank you very much, Eugene. And we will leave the questions for offline. If you have any questions, feel free to go one-on-one offline with Eugene, and I guess you will be more than happy to answer those. Thank you very much. So before we jump into the peering personals and the BS for peers, thanks to Rocco again for this. I would like to call. What's that? Are you excited already? No, I know. So I would like to call Yazid from ICANN, will guide us through the DNS resolution services in Rwanda. So welcome, and the floor is yours. I expect you are in the room. Yes, it's coming. Do they know, are they? For the ones who have submitted for peering personals, can you start queuing on my left side, please? Or sitting. So that's it. The floor is yours.
Thank you so much. So hi everyone. My name is Yazid. I work for ICANN. I'm based in Benin, but I cover Africa and Middle East region. I'm technical engagement specialist, mostly dealing with operators, with ISPs, mobile network operators, universities as well, governments, to actually promote DNS-related standards and best practices. Actually, I was supposed to have this presentation with my colleague, Paul. And the worst thing is that AfPIF Kigali was supposed to be the place we will be meeting physically for the first time, because both of us have been actually hired at ICANN just prior to the lockdown. He was based in Nairobi, Kenya, while I was based in Benin. So we have never physically met, but of course, thanks to the internet, we have been working together for 2.5 years. Some of you know him very well, and you know how lovely Paul was. So if you accept, please let us have 1 minute silence in his memory, please. Thank you very much. So this work we did together is to actually talk about the latency to access the root servers instances. Of course, we have 13 root servers, but thanks to Anycast technologies, each of the root server operator actually installed or deployed various instances at different places around the world. And today we have more than 1,300 individual instances around the world. So the work we did was actually to understand what is the experience of the networks in Rwanda accessing the local root server instances here. But I will start this presentation very briefly because this is important for the next part of the presentation. Thanks to APNIC, LabStat. APNIC is the Asia Pacific RIR and the Regional Internet Registry. So they host a lab and they publish some interesting data related to some internet related stuff like IPv6 adoption, recursive resolvers used by different networks, DNSSEC validation, etc., etc. So when you look at this table very quickly, we can this table, of course, focus on Rwandan networks, and you can see that some ISPs or some operators actually resolve DNS, and Josiah has mentioned about DNS a bit in his presentation. So, of course, there is no real good or bad way to actually deploy your resolvers internally or use maybe some public resolvers. There are pros and cons for both methodologies. Some even use their own resolvers, but behind that, they also use public resolvers. But very briefly, we can see that Airtel, for instance, mostly use GPDNS. Most of the DNS resolutions is done by Google, while other networks such as MTN or GVA, they seems to be using some internal recursive resolvers. Now, coming back to the root servers instances in Rwanda, there are 5, D, E, F, I, and J. And the study, again, we try to understand what is the experience from different networks reaching each of those root servers. And why did we do that? It actually helped to understand what could be the duration for the resolvers to initialize. I won't go into the detail, but there is a process for a resolver to actually measure the latency to each root servers, because in the DNS resolution process, the recursive resolver will from time to time reach out to the root servers to get the query, the user's queries resolved. Now, on the other side, this measurement also help to understand what could be the overall DNS resolution process for those operators who resolve in-house, as I just mentioned from the previous table. So the methodology was quite simple and very short. Of course, it also had some limitations. So we also used the RIPE Atlas probes. We found 3 which were really connected in Rwanda. One from GVA, Canal Box, another one from Airtel, and the last one from Liquid Telecom. And we used the built-in ping measurements from each of those probes. Of course, JRoot doesn't allow those ping measurements. And in addition to that, we also run some one-off DNS measurements to actually understand some specific patterns we found during the analysis. The measurement periods was just from the 1st to the 31st July, so all the month of July. But because, you know, those probes from time to time, they get disconnected. So we isolated some days, and we focus on those days where we found all the 3 probes really connected. It was from the 1st to the 7th of July and the 14th to the 21st of the same month. Now, coming to the limitations, of course, not all networks were covered, because again, the probes were not available in all networks. We just used three probes actually, because this is what we found as really connected from Rwanda. The location of the probes also really varies, and we don't exactly know, but definitely this would also affect and add some latency. But at least the real objectives is to understand what is the latency to bind to those root servers. And of course, we didn't cover IPv6 also. So coming to the observation very quickly, we found that DI and E root servers were quite accessible from all of those probes, and showing latency around 10 milliseconds. And from GVA and Liquid Telecom, mostly the experience was quite good. But when we dig deeply, we found some interesting differences from one network to another. But overall speaking, Liquid Telecom was also showing the overall lowest latency to all root servers. I'm not doing any promotion to any network operator, but this is what we have seen actually. But also, they were presenting the highest latency to one of those root servers, which is M. But it's not, of course, there are some root server operators who do not really deploy their instances. I think for M, they have less than 10 instances all around the world, so it's not really surprising. Other observations, some latency from Airtel probe. Interesting because, again, thanks to peering and all those interconnection, the instance, I think it's H, yes, from Johannesburg is showing the same latency as the F root server instance, which is here in Kigali. And almost the same for Liquid Telecom, for F, H, K, and L. H, K, and L from Johannesburg. So again, as Josiah also mentioned, we can see all the pros, all the advantages we can get from all of you talking and peering and interconnecting between each other. And of course, I won't go into deep details because we seem to be in rush, but something important which needs to be investigated from Liquid again. We have seen some timeouts from D and J root servers. This is a bit surprisingly, and it needs some investigation to understand why for very long periods. And it was not just only in July. We have checked in March, April, and even I think February. It also happened, and that needs to be investigated. So as takeaway, very briefly, of course, there is always a cost to reach the root servers. But yes, there is a kind of new technology called hyperlocal, which help to have all the root server, all the root zone information directly available locally on the resolver. But that one also has its own challenge. And of course, as we mentioned, peering and interconnections always improve the things. And yes, that investigation is also important to do. Very briefly, because we also have a lot of operators here, I'm going to talk about DNSSEC validation, which is actually a security-related topic. The context, again, talking about the DNS, of course, we know the criticality of the DNS on the internet. And today, most of the attacks conducted on the internet are using, unfortunately, the DNS weaknesses. And of course, we need to deploy all those solutions that can actually help to reduce the likely to conduct such kind of attacks. And DNSSEC validation is one of them. Very briefly, DNSSEC can be compared to the same issue we have with banknotes. You know, central bank, or they used to deliver, to produce the banknotes, and they actually implement right mechanisms to detect counterfeits banknotes. So whether you go into a shop, you go into a mall, there are different ways to actually verify your banknotes. It's exactly the same way DNSSEC actually works. There is a part to sign the data and the other part to actually verify that information. And we work with a lot of operators who have their own internal recursive resolvers to help them actually activate that DNSSEC validation in the resolvers to make sure that for every single DNS request which is going through the resolver. As soon as the zone is signed, the resolver can do the verification, the validation, and protect the end users. Very briefly, there is still a lot of work to do. Sorry, I think I missed that part. Yes, here in Rwanda, but not only, we can see a lot of reds in the region, and not only in East Africa. There is still a lot to do, and I will be more than welcome to talk with the respective operators to actually implement that DNSSEC validation and protect our end users. I think that's all. I want to go much into more details because, again, we are in lack of time. And thank you, everyone. I'm glad to receive any question if there is. Thank you.
Thanks a lot, Yazid. Well, thanks for everybody. Just be here with us. We're gonna end up with some gifts, and I will ask the previous speakers to join us, and then we hand over to Frank for the peering personals. Coming? Yes. I think the LINX guy, he left. Yes. We are missing one. Oh, there, JB.
Is Halil hiding in the room? Oh, we'll find Halil later.
Thank you very much. Appreciate it. Oh, Eugene, thank you very much. Much appreciated. Josiah, thank you very much. GB, this one is for me, right? No, I'm joking. Thank you very much. Thanks, guys. Very well done.
Okay, hello, sorry, it's me again. Now I did a big mistake. To not notice that the one we were missing the first time was actually a remote participant on Zoom. And now he's not online anymore, sorry. So we're preparing to have one more remote participant if he's able. And then I request all the others to have sent already to come close to the stage. James, come. We don't have much time. I promised everybody to finish this in 5 minutes. So only a few seconds for everybody. Main one and Javier from Rogers Capital, Donald from INX, Matthew or somebody from Liquid Intelligent Technologies, long name, who's coming here. And Ono from AM6 and Safaricom. Is the team up? Please come up one after the other. The first question goes to Enoch. Yes, we don't have him online, so it will be not with remote presenters, but you can see the ASNs of the ones who are remotely who have submitted their data. Please take a picture. They are only there for 10 seconds if they are interested in peering. And unfortunately, this is all the information we have, but their AS number is there, peering DB contacts are there. And Enoch, next slide. And this is the other one. EcoBand Networks in Ghana is also interested to present themselves here. They will probably during the meeting be on Zoom available. Okay, then we start with 2 times James.
Hello, my name is James from Arusha Internet Exchange, the second internet exchange in Tanzania. The PRE policy is open and you can reach us via info@ixp.org. Also, I'm from Habari now, the ISP also in Tanzania. We are connected at TXC, IXP, DXP, and it's open policy also. You can reach us by that address. Thank you.
Hi everyone.
What's up here? Cool. No, what's you? Next slide. Next slide. That's you?
Yeah. Yes. Hi everyone. I'm Ranvir from Rogers Capital Technology. So we are present today in all the Indian Ocean islands and in some Eastern African countries. So our AS number is 36868. We have an open peering policy. Today we are peering at MIXP, JINX, NAP, and LINX. So you can reach out to us at IPCO at rogerscapital.mu. Thank you.
Hi, my name is Donald. I'm from LINX ZA. We are the oldest internet exchange point in Africa. That's JINX. We have 3 exchange points, JINX, SYNX, and LINX. JINX being in Johannesburg, SYNX in Cape Town, LINX in Durban. We are a multi-site, multi-city exchange, but multi-site only within the city. We are 100% community run, and we are the JINX, LINX are the first IXPs to receive the OIX1 certification from OpenIX in Africa. You can get hold of us at ops@INX or search for us on PeeringDB. Thank you.
Good evening. My name is Matthew Chigwende. I'm from Liquid Intelligent Technologies. I'm from Liquid Intelligent Technologies. We have a network that covers all of Africa and beyond. In terms of peering, we are generally open and we love to peer with everyone. And we are in internet exchange points in Europe, mostly in the big internet exchanges like AM CDT, and also in the USA, MI3. We are also in all parts of Africa, like in the Southern Africa, East Africa, and Central Africa. And we love to peer, and we love to talk about peering as well. And also all our details will be on PeeringDB, and all you have to do is send an email to us on peering@liquid.tech. Thank you.
Thank you, Matthew.
Good afternoon. We are Petra and Onno from M6. If you want to know what we do at M6, please visit our booth. We are sitting over there. So we look forward to seeing you there, and have a great evening. Thank you.
Hello, good evening. Good evening. My name is Tima. I'm representing Safaricom PLC from Kenya. Our ASN is 33771. We have our points of presence at Kenya Internet Exchange, ADC, and ICOLO. We have an open policy. My contacts are on the screen. Reach out to me for collaborations. Thank you.
Okay, next on stage is Program Committee. Housekeeping, anyone? You're behind time, quick.
Thank you as ever, Frank, our most popular speaker. Comes back every year, several times. Anyway, thank you all for coming along all day. We had some interesting presentations for your particular interests. We start again at 9 o'clock tomorrow, not 9:30 as the agenda says, with peering bilaterals till 10:30. And then we go in, we have a coffee break, and then we go into the official opening with the minister from the Rwandan government and our keynotes. There'll be more peering personals, of course, so please sign up. And meanwhile, Beers for Peers, which apparently is also a popular thing that comes along every year and people seem to like. So it's out on the terrace. Thank you to Terraco for organizing and sponsoring it. Thank you again to all of our sponsors who all make this possible. Thank you to ISOC and all the organizers, my fellow PC members, and have a fabulous evening. Thank you.